On the evening of February 5, 1958, during a period when the United States maintained large numbers of nuclear-armed aircraft as part of its strategic deterrent posture, a routine training mission over the southeastern United States began to unravel into an event that would eventually leave a thermonuclear weapon resting somewhere beneath the coastal waters near Savannah, Georgia. The aircraft involved was a Boeing B-47 Stratojet, a six-engine jet bomber that formed the backbone of the Strategic Air Command's nuclear strike force during the 1950s. The B-47 was designed for high-speed penetration of Soviet airspace and was capable of delivering nuclear weapons against strategic targets if war broke out between the United States and the Soviet Union. On that February night, the bomber was operating out of Homestead Air Force Base in Florida as part of a training exercise that simulated a nuclear strike mission. These exercises were common during the early Cold War because Strategic Air Command required its crews to rehearse the procedures associated with nuclear weapons delivery, including long-distance navigation, aerial refueling, and simulated attack runs. The B-47 on this particular mission carried a Mark 15 hydrogen bomb in its bomb bay, a thermonuclear weapon significantly more powerful than the atomic bombs used during the Second World War. The bomb was not intended for use during the exercise itself. It was part of the aircraft's standard training configuration, and according to official records, its nuclear core had not been installed, meaning that although it contained the high explosive components associated with the weapon, it did not possess a fully assembled nuclear package capable of producing a thermonuclear explosion. Even so, the device remained a large and complex piece of military hardware, weighing several tons and containing components designed for use in one of the most destructive weapons ever built. The training mission was proceeding. Normally, when the B-47 approached the coastline of Georgia late in the evening. At roughly the same time, an F-86 Sabre jet fighter was also participating in a separate training exercise in the same general region of airspace. Air Force training operations frequently involved multiple aircraft conducting independent missions in overlapping areas, relying on navigation procedures and communication with ground control to maintain safe separation. However, on that night, a series of circumstances caused the two aircraft to converge unexpectedly. The fighter pilot was practicing intercept procedures designed to simulate the interception of enemy bombers, while the B-47 crew was conducting navigation maneuvers associated with long-range strike missions. As the aircraft approached each other in the dark sky over coastal Georgia, the pilot suddenly realized they were on a collision course. Despite last-second evasive maneuvers, the F-86 struck the B-47 from below, tearing into the bomber's right wing and damaging one of its engines. The impact caused significant structural damage to the bomber and sent the fighter jet spinning away. The pilot of the F-86 managed to eject safely from his aircraft before it crashed, but the B-47 remained airborne, albeit with severe damage that made continued flight uncertain. Inside the B-47 cockpit, the crew immediately assessed the situation. The collision had compromised the bomber's wing structure and damaged its fuel system, leaving the aircraft struggling to maintain altitude. The pilot realized that attempting to land with the heavy hydrogen bomb still inside the bomb bay could be extremely dangerous. In the event of a crash landing, the high explosives within the weapon could detonate on impact, potentially destroying the aircraft and endangering anyone nearby. The crew therefore faced a critical decision. To increase their chances of safely landing the damaged aircraft, they needed to lighten the bomber by releasing the bomb before attempting to reach the nearest airbase. After communicating with ground controllers and receiving authorization, the crew prepared to jettison the weapon over open water. The selected area was Wassaw Sound, a stretch of coastal water between the barrier islands east of Savannah, Georgia. At approximately 7:30 p.m., as the damaged bomber descended toward the coast, the crew opened the bomb bay and released the Mark 15 weapon into the darkness below. The bomb fell into the waters of Wassaw Sound, somewhere between Tybee Island and the mouth of the Savannah River. Because the drop occurred at night and under emergency conditions, the crew could only estimate the location where the weapon had entered the water. Once the bomb had been released, the B-47 was able to climb slightly and stabilize its flight. Despite the damage sustained during the collision, the pilot managed to guide the aircraft toward Hunter Air Force Base near Savannah, where the bomber eventually made a successful emergency landing. The crew survived the incident, but the release of the hydrogen bomb immediately triggered a major search operation. Strategic Air Command and the United States Air Force recognized that a nuclear weapon had been lost in coastal waters near a populated region. Although the bomb was believed to lack its nuclear core, the possibility that sensitive military equipment had been lost created both a security concern and a public safety issue. Within hours of the incident, the Air Force began organizing search efforts to locate the missing weapon. Military personnel deployed aircraft, ships, and divers to the waters around Wassaw Sound in an attempt to determine where the bomb had landed. The search operation involved both visual inspection of the water surface and underwater scanning techniques intended to detect metallic objects resting on the seabed. However, the geography of the region complicated the effort from the beginning. Wassaw Sound lies along a section of coastline characterized by shifting sandbars, tidal currents, and muddy seabed conditions that can quickly bury objects beneath layers of sediment. The depth of the water in the search area varied, but in many locations it was shallow enough for tidal movement to stir the seabed continuously. This meant that a heavy object, such as the Mark 15 bomb, could sink into soft sediment shortly after impact and become increasingly difficult to detect as sand and mud accumulated around it. For several weeks, Air Force personnel conducted an extensive search of the Sound. Naval vessels equipped with sonar scanned the seabed, while divers explored areas where the bomb might have settled. Aircraft flew overhead, looking for any sign that the weapon had broken apart or floated to the surface. Despite these efforts, the search teams failed to locate the bomb. The estimated drop location provided by the B-47 crew was necessarily imprecise because the release had occurred at night while the aircraft was descending under emergency conditions. As investigators expanded the search area, the number of possible locations where the weapon might have landed increased dramatically. The tidal currents in the Sound also meant that if the bomb had fallen into deeper channels, it might have been carried or buried beneath layers of sediment almost immediately. After weeks of searching without success, the Air Force eventually concluded that the weapon could not be located with the available technology. In April 1958, the search was officially suspended, and the missing Mark 15 hydrogen bomb was declared irretrievably lost. The official assessment stated that the weapon posed no danger to the public because it lacked the nuclear capsule required for thermonuclear detonation. According to this explanation, the device resting on the seabed contained only the high explosive components used to initiate the nuclear reaction, but without the plutonium core, those explosives could not produce a nuclear blast. As a result, the Air Force maintained that the bomb represented no significant hazard to the surrounding area. Despite this official position, the disappearance of a hydrogen bomb just a few miles from the Georgia coastline inevitably attracted attention in the years that followed. Local residents occasionally speculated about the location of the missing weapon, and fishermen operating in the waters near Tybee Island sometimes wondered whether their nets might one day snag the bomb. Over time, the story of the lost weapon became part of regional folklore, a Cold War relic resting somewhere beneath the waters of Wassaw Sound. For decades, the official Air Force position remained unchanged. The bomb had been lost during the 1958 training accident. The search had failed to recover it, and the device posed no danger because it lacked the nuclear material necessary for detonation. Yet the uncertainty surrounding the weapon's exact configuration and location would eventually lead to renewed interest from private researchers and scientists who questioned whether the bomb might still contain components capable of posing a risk. These investigations, conducted decades after the original accident, would reopen the debate about what exactly had been dropped into the waters near Tybee Island, and whether the missing hydrogen bomb truly represented no hazard to the surrounding region. In the weeks following the emergency release of the Mark 15 hydrogen bomb into Wassaw Sound, the United States Air Force initiated one of the most extensive search efforts ever conducted along the Georgia coastline, mobilizing both military and civilian resources in an attempt to locate the missing weapon before shifting tides and sediment could bury it permanently beneath the seabed. The search began almost immediately after the B-47 crew safely landed at Hunter Air Force Base and reported the jettison of the bomb. Strategic Air Command recognized that although the weapon was believed to lack its nuclear core, it still represented a highly sensitive piece of military hardware containing classified components and powerful high explosives. The prospect of such a device lying unaccounted for near a major American port created both a security concern and a public relations problem that the Air Force wanted resolved quickly. Within hours of the accident, search aircraft began flying systematic grid patterns over Wassaw Sound, while naval vessels equipped with sonar attempted to scan the ocean floor for large metallic objects. Divers were dispatched to investigate any anomalies detected by sonar returns, and additional ships joined the operation as the search area expanded. At first, investigators focused on a relatively small section of the sound, based on the B-47 crew's estimate of where the bomb had been released, but the accuracy of that estimate was limited by the conditions under which the release occurred. The bomber had been descending rapidly after, suffering structural damage in the collision with the F-86 fighter, and the crew had released the weapon at night while attempting to stabilize the aircraft. As a result, their estimate of the drop location could only approximate the true point of impact. The geography and hydrology of Wassaw Sound complicated the search from the beginning. The sound forms part of the intricate coastal system of tidal inlets and barrier islands that characterize the Georgia coastline. Strong tidal currents move large volumes of water in and out of the sound twice each day, stirring the seabed and shifting sandbars across the shallow channels between islands. Much of the bottom consists of soft mud and silt that can easily swallow heavy objects. When the Mark 15 bomb struck the water, its several-ton mass would have driven it downward through the sediment layer before coming to rest. Within hours or days, additional sediment could have accumulated around the object, burying it beneath the seabed. Search teams therefore faced the challenge of locating a metal object that might already be partially or completely buried beneath shifting layers of sand and mud. Sonar equipment available in 1958 had limited resolution compared with modern technology, making it difficult to distinguish between a buried bomb and natural geological formations on the seabed. Despite these obstacles, the Air Force conducted a systematic effort to locate the weapon. Ships equipped with magnetometers attempted to detect disturbances in the Earth's magnetic field, caused by large metallic objects beneath the water. Divers explored promising locations identified by sonar scans, descending into murky water, where visibility was often reduced to only a few feet due to suspended sediment. Aircraft continued to search from above, hoping that unusual patterns on the water surface might indicate where the bomb had entered the sound. The operation continued for weeks, with military personnel carefully documenting each section of seabed examined during the search. Yet as the days passed without success, the search area grew larger, and the likelihood of locating the bomb decreased. Every tidal cycle potentially shifted sediment and buried the weapon deeper beneath the ocean floor. By early April 1958, the Air Force had reached a difficult conclusion. Despite extensive efforts involving ships, divers, aircraft, and specialized detection equipment, the Mark 15 bomb could not be located. The search had covered a large section of Wassaw Sound without producing any definitive evidence of the weapon's location. Continuing the operation indefinitely would require significant resources while offering diminishing chances of success. On April 16, 1958, the Air Force officially suspended the search and declared the weapon irretrievably lost. In public statements, officials emphasized that the bomb did not contain its nuclear capsule and therefore could not produce a nuclear explosion. According to the Air Force explanation, the weapon's nuclear core had been stored separately and had not been installed during the training mission. Without that core, the bomb's thermonuclear reaction could not occur. The device resting on the seabed therefore consisted primarily of conventional high explosives and structural components rather than an operational nuclear weapon. This official assessment became the foundation of the government's position regarding the Tybee Island bomb in the decades that followed. Air Force statements consistently maintained that the missing weapon posed no hazard to the public or to the environment. The high explosives inside the bomb were considered stable under the conditions present on the seabed, and the absence of nuclear material meant that there was no risk of radioactive contamination or nuclear detonation. From the perspective of military planners, the incident represented an unfortunate accident, but not an ongoing threat. As a result, the government did not attempt additional recovery operations once the initial search had been suspended. However, the disappearance of a hydrogen bomb just a few miles from the American coastline inevitably attracted attention over time, particularly as Cold War secrecy gradually gave way to greater public interest in nuclear weapons history. During the 1960s and 1970s, occasional references to the lost bomb appeared in newspapers and local discussions around Savannah and Tybee Island. Fishermen operating in the waters of Wassaw Sound sometimes wondered whether the weapon might be resting somewhere beneath their boats, and the story of the lost bomb became part of the region's historical lore. For the most part, though, the issue remained dormant because the Air Force had concluded that the bomb posed no danger. Interest in the missing weapon revived periodically as advances in detection technology suggested that locating the bomb might now be possible. Magnetometers, side-scan sonar, and other instruments used in underwater archaeology had improved dramatically since the 1950s, making it theoretically easier to identify large metallic objects buried beneath sediment. In the early 21st century, several private researchers began attempting to locate the bomb independently of the government's earlier search efforts. One of the most widely publicized attempts occurred in 2004 when a retired Air Force officer named Derek Duke conducted a private survey of the sound using modern magnetometer equipment. Duke reported detecting an unusual magnetic anomaly near the mouth of the Savannah River that he believed might correspond to the missing bomb. The discovery attracted attention from both local media and scientific observers, raising the possibility that the long-lost weapon might finally be located after nearly half a century. The Air Force reviewed the findings of Duke's survey, but ultimately concluded that the anomaly he detected was unlikely to be the Mark 15 bomb. Officials suggested that the magnetic signal could have been caused by natural mineral deposits or other metallic debris on the seabed, rather than the weapon itself. The government reiterated its position that the bomb did not contain nuclear material and therefore posed no danger even if it remained undiscovered. Nevertheless, the renewed search efforts reignited debate about what exactly had been lost in 1958 and whether the official explanation about the bomb's configuration was entirely accurate. Some scientists questioned whether the weapon might still contain components capable of posing environmental or explosive risks, while others argued that the Air Force's original assessment remained technically sound. As private investigators continued examining historical records and conducting limited surveys of the seabed, the mystery surrounding the Tybee Island bomb persisted, leaving unanswered questions about the exact location and condition of the hydrogen bomb that had been dropped into the waters off Georgia more than 6 decades earlier. In the decades after the search was suspended and the Mark 15 weapon was declared irretrievably lost, the official explanation offered by the United States Air Force remained largely unchanged. The bomb had been jettisoned into Wassaw Sound during an emergency in February 1958. Extensive recovery operations had failed to locate it, and the device did not contain its nuclear core, meaning that it posed no danger to the public or the surrounding environment. According to this position, the weapon dropped by the B-47 bomber was a training configuration that included the bomb's casing and high explosive components, but lacked the plutonium capsule required to initiate the nuclear chain reaction. In that configuration, the bomb could not produce a thermonuclear explosion, even if its high explosives were somehow triggered. Air Force statements over the years repeated this explanation, emphasizing that the device resting somewhere beneath the sediment of Wassaw Sound represented no ongoing hazard. Yet the disappearance of a hydrogen bomb so close to the American coastline continued to attract periodic scrutiny from researchers, historians, and independent investigators who sought to verify exactly what had been lost and whether the official description of the weapon's configuration was entirely accurate. Part of the uncertainty surrounding the Tybee Island bomb stems from the nature of nuclear weapon design during the 1950s. Thermonuclear weapons, such as the Mark 15, were complex systems composed of multiple components that could be assembled or removed depending on operational requirements. The nuclear capsule containing plutonium was one such component. During some training missions, the capsule was indeed removed for safety reasons, leaving the weapon incapable of producing a nuclear explosion. However, documentation from the era sometimes used ambiguous language when describing whether a particular weapon carried on a training flight was fully assembled or partially configured. Over time, this ambiguity fueled speculation among researchers who examined Cold War records and attempted to determine whether the bomb lost near Tybee Island truly lacked its nuclear material. Some investigators suggested that the bomb might still contain at least part of the weapon's nuclear assembly, while others accepted the Air Force's explanation that the device dropped into the Sound was essentially a non-nuclear training configuration. The debate intensified as private search efforts increased during the early 21st century. Advances in underwater detection technology allowed researchers to survey sections of Wassaw Sound with equipment far more sensitive than the instruments available during the original 1958 search. Magnetometers, capable of detecting subtle variations in the Earth's magnetic field, could identify large metallic objects buried beneath sediment, while side-scan sonar systems could produce detailed images of the seabed. These technologies made it theoretically possible to locate the missing weapon if its approximate position could be narrowed down sufficiently. Independent investigators began examining historical flight records, radar data, and crew testimony in an attempt to refine the estimated drop location provided by the B-47 crew decades earlier. One of the most widely discussed search efforts was conducted by Derek Duke, the retired Air Force officer who used magnetometer surveys to investigate the waters off Tybee Island in 2004. Duke believed that he had detected a large metallic object buried beneath sediment near the mouth of the Savannah River, an area consistent with some interpretations of the bomber crew's estimated release point. His findings generated considerable media attention and prompted renewed questions about the location of the missing bomb. However, when the Air Force reviewed the data from Duke's survey, officials concluded that the magnetic anomaly could not be definitively identified as the Mark 15 weapon. They suggested that the signal might be caused by naturally occurring magnetite deposits in the seabed or by other metallic debris unrelated to the bomb. Without excavation or more detailed imaging, it was impossible to confirm the object's identity. The government declined to authorize a recovery operation, maintaining that the bomb posed no hazard and that disturbing the seabed might create unnecessary complications. Scientists who examined the issue have sometimes expressed differing views about the potential risks associated with the missing weapon. Supporters of the Air Force position argue that even if the bomb remains intact beneath the sediment, the absence of its nuclear capsule means it cannot produce a nuclear explosion. The high explosives inside the weapon, they note, are designed to detonate only under very specific conditions and are unlikely to explode spontaneously after decades underwater. From this perspective, the bomb represents little more than a large piece of military hardware resting on the seabed. Other researchers, however, have suggested that the situation may be more complex. They note that the high explosive components within the bomb were designed to compress the nuclear core during detonation, meaning they are powerful and carefully engineered charges. While these explosives are generally stable, their long-term condition after decades underwater is difficult to predict with certainty. Some scientists have also raised questions about whether radioactive materials could be present in trace amounts, even if the primary nuclear capsule was absent. Despite these debates, the U.S. government has consistently maintained that the missing weapon presents no meaningful threat. Official assessments conducted over the years have concluded that the bomb's configuration and the conditions of its burial beneath sediment make it extremely unlikely to pose either an explosive hazard or an environmental risk. The waters of Wassaw Sound continue to support commercial fishing, shipping traffic entering the port of Savannah, and recreational boating activities along the Georgia coastline. For most residents of the region, the existence of the lost hydrogen bomb has become more of a historical curiosity than a source of concern. Yet the story of the Tybee Island bomb persists because it illustrates the unusual circumstances under which nuclear weapons were handled during the early decades of the Cold War. In the 1950s, the United States maintained large numbers of nuclear-armed aircraft ready to respond to potential conflict with the Soviet Union. Training missions involving bombers carrying nuclear weapons were conducted routinely across American airspace, reflecting the strategic urgency of maintaining readiness during a period of intense geopolitical rivalry. The mid-air collision over Georgia in 1958 revealed how those operations could produce unexpected consequences when accidents occurred. A single training mission intended to simulate a nuclear strike had resulted in the loss of a hydrogen bomb just miles from the American coastline. More than 60 years after the incident, the exact location of the weapon remains unknown. Somewhere beneath the shifting sediments of Wassaw Sound, possibly buried beneath layers of sand and mud carried by the tides, lies the Mark 15 hydrogen bomb released from the B-47 bomber during that February night in 1958. The original search failed to locate it, and subsequent private investigations have not produced definitive confirmation of its position. The Air Force continues to describe the weapon as irretrievably lost, and no further recovery operations have been planned. For historians of the Cold War, the Tybee Island incident stands as one of the most unusual nuclear accidents of the era, a moment when the intersection of routine training operations and mechanical failure left a thermonuclear weapon resting on the ocean floor just beyond the coastline of the United States. More than 6 decades after the collision that forced the B-47 crew to release the Mark 15 hydrogen bomb over the waters near Tybee Island, the missing weapon remains one of the most unusual, unresolved relics of the Cold War, resting somewhere beneath the shifting sediments of Wassaw Sound, where tidal currents and coastal erosion have continually reshaped the seabed since the night it fell. Over time, the physical environment of the sound has changed repeatedly as sandbars move, channels deepen or fill, and sediment accumulates in layers across the muddy bottom. If the bomb came to rest in one of the deeper tidal channels, it may now be buried beneath several meters of sediment, making detection extremely difficult, even with modern sonar and magnetometer technology. In other parts of the Sound, shifting sandbars may have gradually covered the weapon as tidal flows carried sand and silt across the seabed year after year. This constant geological motion is one of the primary reasons why the original search, conducted in 1958, struggled to locate the bomb, and why later private search efforts have also failed to confirm its location. Each passing decade makes the prospect of recovering the device more uncertain as sediment layers grow thicker and the surrounding terrain becomes more difficult to interpret. The continued presence of the bomb beneath the waters near Savannah has occasionally prompted questions from residents, researchers, and journalists about whether the device should be recovered if its location were ever confirmed. The official position of the United States Air Force remains that recovery is unnecessary because the weapon does not contain its nuclear capsule and therefore cannot produce a nuclear detonation. According to this assessment, the bomb is essentially an inert military artifact resting on the ocean floor, posing no risk to public safety or the environment. Officials have also noted that attempting to excavate a large object buried beneath coastal sediments could create unnecessary disturbance in a sensitive marine environment and would require complex engineering operations to ensure that the device could be handled safely. From this perspective, the most practical course of action is simply to leave the weapon undisturbed. Yet the mystery surrounding the Tybee Island bomb continues to attract interest because it highlights how nuclear weapons were integrated into everyday military operations during the early Cold War. Strategic Air Command maintained a vast network of bombers capable of delivering nuclear weapons across the globe, and training missions involving live weapons were conducted regularly to ensure that crews could perform their tasks under realistic conditions. These exercises were designed to maintain readiness in a world where military planners feared that a nuclear conflict with the Soviet Union could begin with little warning. In that strategic environment, the presence of nuclear weapons aboard training aircraft was considered routine rather than extraordinary. The accident over Georgia in 1958 demonstrated that the systems supporting that strategy were not immune to the kinds of mechanical failures and human decisions that affect all complex operations. A mid-air collision between two aircraft conducting separate training missions had forced a bomber crew to make a rapid decision about how to protect themselves and their aircraft. Jettisoning the weapon into the water allowed them to land safely, but it also left a thermonuclear device resting on the seabed just a few miles from the American coast. The Tybee Island incident is one of several Cold War accidents sometimes referred to collectively as broken arrow events, a term used by the U.S. military to describe incidents involving nuclear weapons that do not create a risk of nuclear war. These events include accidents in which nuclear weapons are lost, damaged, or accidentally released without detonation. Over time, declassified records have revealed a number of such incidents occurring during the decades when nuclear forces were maintained at high readiness levels. Each event provides insight into the operational realities of managing nuclear arsenals during the Cold War. In the case of the Tybee Island bomb, the combination of a mid-air collision, emergency decision-making, and difficult environmental conditions produced an outcome that remains unresolved even after more than 60 years. The continued interest in the lost bomb also reflects the broader historical fascination with the hidden infrastructure of the nuclear age. Many aspects of Cold War nuclear operations remained secret for decades, and only gradually have documents and records become available that allow historians to reconstruct what happened during those years. The disappearance of the Mark 15 bomb near Tybee Island was initially reported only in limited terms, with few details about the circumstances of the collision or the nature of the weapon involved. Over time, however, additional information emerged through archival research and declassification, allowing a clearer picture of the event to form. The story now occupies a distinctive place in the history of nuclear weapons accidents because it combines several unusual elements: a mid-air collision between two military aircraft, the emergency release of a hydrogen bomb over coastal waters, an extensive but unsuccessful search operation, and the continuing mystery of a weapon that has never been recovered. Today, the waters of Wassaw Sound appear no different from any other stretch of coastline along the southeastern United States. Fishing boats move through the channels between barrier islands. Cargo ships enter and leave the busy port of Savannah, and tourists visit nearby beaches without realizing that somewhere beneath the shifting sediments of the Sound lies a relic of the Cold War. Whether the bomb will ever be located remains uncertain. Advances in underwater detection technology could one day allow researchers to identify the weapon's resting place with greater precision. But even if its position were confirmed, the question of whether it should be recovered would remain open to debate. For now, the Mark 15 hydrogen bomb dropped by a damaged B-47 bomber in February 1958 remains officially classified as irretrievably lost, a silent artifact of the nuclear age resting beneath the coastal waters of Georgia, and a reminder of how the strategic realities of the Cold War sometimes left unexpected legacies in the landscapes of everyday life.